Today we're going to be working on Leetcode question number 99, recover binary search tree. So you are given a root of a binary search tree BST where the values of exactly two nodes of the tree were swapped by mistake. Recover the tree without changing its structure. So in this example, 3 and 1 were swapped, and if we swap them, it's going to become a valid binary search tree. In the example number 2, 3 and 2 have been mistakenly swapped, and if we swap them, it's gonna become a valid binary search tree. The way we're gonna be doing it is basically we're gonna try to find the two nodes while doing the in-order traversal, and once we find them, we're gonna swap them. So let the previous first and second without even defining them. So we have three variables here. We're gonna have our in order function, which is gonna take the root. So this is gonna be the in order function. We're gonna call this in order function by sending the root in it, and once we do that, we're gonna say that let the temp is equal to, we're just gonna swap it after that. First dot value, first dot value is gonna be equal to the second dot value. Oops. And then the second dot value is gonna be equal to 10. So what's gonna happen in order traversal is, again, if the root is null, we're gonna return we're just gonna return. Otherwise, we're gonna go to the left by in order traversal root dot left, and then once we are there, we're gonna do our logic, and then we're gonna send in order to the root dot right. That's basically the in order traversal. So now we're gonna write our logic that if the previous does exist and the previous dot value is greater than the root dot value. If that is the case, we have a problem because the binary search tree, this shouldn't be right. So in that case, we're gonna say that if the first first does not exist, right, we're gonna set the first. Basically, we are trying to set the first only once. So if we haven't set the first before, we're gonna say that the first is basically equal to previous. Okay, and the second is going to become equal to the root, and previous every single time, whether this condition is right or not, we're gonna update the previous to root. Okay, so previous is gonna always get updated to root. Second, if we are inside this condition that we have found out that the current root dot value is greater than the previous dot value, provided the previous does exist, we're gonna say that the second is equal to root, and the first one we are only gonna set it up once. So the first time we're gonna set up the once, otherwise it's only gonna be the second which is gonna get updated. Yep, and it passed all the test cases.